Hello everyone, welcome to Rila Academy. In this video series, we are going to see power electronic converter design using MATLAB. As the first video of the series, let's see how to design DC to DC buck converter. Let's go with step-by-step process. First, we need to identify the circuit of the buck converter. In here, you can see the circuit diagram of the buck converter. So the first step of the converter design, we need to decide the value of the duty cycle and ripple factors. Uh, so what is duty cycle? Duty cycle means the ratio between output voltage and input supply voltage. And the ripple factors, there are two ripple factor, current inductor ripple current factor and the output voltage ripple factor. So here, generally, we are considering the output inductor current ripple factor 20 percentage to 40 percentage of the output current, and the output ripple voltage will be considered as 0.5 to 2 percentage of the output voltage. So these are the things we have to select as the designing purposes, and also we need to select switching frequency of the switch. So based on this value, we have to calculate inductor value and the capacitor value of the buck converter. So for our design, here we select the output voltage as 6 voltage and input voltage as 10 voltage, and our duty cycle ratio will be 0.6. And here we are considering 25 percentage of the uh, ripple current factor and the 1 percentage of the ripple voltage factor, and the switching frequency will be 20 kilohertz, and load resistor will be 10 ohm. So based on these things, if we calculate the output current, that will be 1 ampere, and the inductor will be 480 microhenry, and the capacitor 26 microfarad. Now let's start to simulate these things. So first, what we have to do is we have to put the DC voltage source. So DC voltage. So here we are going to use this DC voltage, this one DC voltage source, and then switch. So IGBT, basically IGBT with diode. So yeah, so then we need a diode. Control. Yeah, we have protected one. This one. Okay. Then in here, the main thing is we have to set this voltage, sorry, forward voltage as 0, because here we are considering our diode as an ideal diode, right? So then only we can get these things. Okay. So we are setting our forward voltage will be 0 and apply OK. Then what we have to do select is our inductor. Let's then inductor. For the inductor, yeah, we have to RLC, yes, series RLC branch. Then go to that one, and we have to make it for inductor, and the value will be 480 microhenry. So 480 micro into the power minus 6. Then apply. Then it will be inductor. Okay. First I will connect these things. Okay. It will be easy. So, inductor. And yeah, capacitor. So that one also have select RLC series, and take that one and make it as the capacitor. The value will be 26. Yeah. So then our load resistor. Okay. So basically, I designed this circuit using this using this circuit configuration. Okay, then same RLC series branch. I'll also rotate this one, make it as the resistor here. The resistor value will be 10, which I am selected. So yeah, so basically this is my circuit. So here, that's all. So my input voltage. So yeah, input voltage will be 10 voltage here. These are the initial thing I have to select. Okay, what is the input voltage and output voltage? What I need from this uh, buck converter. Okay, my buck converter supply will be 10 and output will be 6. So based on that one, I have to select the duty cycle. Then ripple factors and the ripple factors I have to select. Okay, so that are the thing here what I have selected, and also switching frequency. Okay, it's 20 kilohertz based on these things. So I have, and also I have to select what is my output load. Okay, so these are the designing thing which I have to select. So based on this thing, I have to calculate what is the output current and an inductor and capacitor based on these equations. Okay. The output current will be easy. It's we output over what resistor. Okay, we output over 10 over this 10, so that will be 1. Okay, these are the basic things. So what we have to do is we have to verify. Now we are getting this 6 voltage as the output. We are giving 10 voltage as the input. We have to select voltage measurement toolbar. Okay, okay. We have to place it like this, and also for we need to display that value. But okay, here we miss a main part of this circuit design. Okay, we miss a main very important part, which is we didn't give the pulse here. Okay, pulse for the switch. So basically, for give pulse, we have to select pulse generator. So pulse generator, we have to select from here. We have to give this pulse. So basically, in the pulse, what we have to do is the amplitude is 1. So period means what is the switching frequency we selected is 1 over 20 kilohertz. So period will be 1 over switching frequency. So 20 kilohertz. So then what is the percentage? So here the percentage is 0.6. It means 60 percentage. Awesome. So no time delay. That's all. And apply. Okay. Now our circuit is done. So what we have to do is we have to run this. Okay. Now let's run the simulation. Yeah, you can see here our value will be show as a 6, around 6. There will be a considerable amount of ripple because we have selected 1% allow 1% of the voltage ripple. That's why. Okay. So yeah, that's all. So subscribe to our channel and like the video and share. Thank you.